Okay, today we're going to start another section of statistics called univariate data. We're going to look at just a list of one set of data, and we're going to figure out what we can talk about when we just have one set of data as opposed to two sets of data. So the first thing we want to understand is how do we gather and display data. Okay, in our vocabulary is qualitative and quantitative data, representative sample, bias, and sampling techniques. And this covers learning, the learning objectives. These are all the statistics objectives in the integrated algebra topic. Categorize data as qualitative or quantitative. Determine when collected data or display of data may be biased. And identify and describe sources of bias and its effect, drawing conclusions from the data. Okay. So first thing we want to go over is the distinction between quantitative data and qualitative data. So quantitative data is numerical data. So some examples are heights of students, test scores, growth of a plant in millimeters, ages of people in a class in years, average rainfall like we saw in our last quiz. Whereas qualitative data is also sometimes called categorical data. So it's data that's in categories. So if you rate something good, bad, or excellent, those are categories, either the category of good, bad, or excellent. Favorite color, so you might see the colors of, blue or black or purple or yellow or orange. Those are all categories. Birthday month. Now, even though you can write the birthday month as a numeral, right? 1, the month of January is 1, the month of February is 2, and so on. Okay, there's no such thing as 1.5. So someone wouldn't say to you, okay, I'm in birthday month 1.5. We don't write that as you're either in month 1 or in month 2. Okay, so they're independent of each other, 1 and 2. There's nobody who's in both 1 and 2 in that category. So instead of it even though birthday month can be written, most of the time it's written as, as names, January, February, and so on, but it can be written with numbers instead. But those numbers don't really represent numerical data. They more represent categories, okay? And the way that you can sort of distinguish between that is, so down here, a good tip for trying to tell whether data is quantitative or qualitative is asking whether or not you can take a mean. Okay, if someone said they were born in February and someone said they were born in March, well, March would be the third month, right? Would you take an average of those two to get 2.5? Would that number mean anything? The answer is no, because no one's in month 2.5. So even if the data is numerals, so it's numbers, if you can't take an average of them, then those are just categories. Okay, a zip code is like that too. So let's say our zip code of our school is 11236, right? So even though this is numerals, it's more of a categorical data than it is numerical. So you wouldn't take two people's zip codes like 11236 and 11216, and you wouldn't add them together to get an average because that number wouldn't mean anything. Okay, so when you can't take a mean or an average, then the data is categorical. Or the other way of mentioning it is qualitative. So the only difference between these two words is one has an L and one has an N for numerical. Okay. Now, collecting data. So it's often very hard to study the entire population that you are interested in. For example, if you are wondering what the average height of a 13-year-old woman in the United States is, so if you ask yourself, okay, I'm wondering what all the students my age, I wonder, what the average heights of those students are. I wonder how I measure up to the average height. Well, the population that you're interested in studying is so large, and you can't possibly study all those things, all those people at once. So a lot of times when the population is large like that, you have to get a sample. So instead of studying the whole population, you have to get a sample. But then it becomes very critical for you to have a sample that's representative of the entire population. Okay, so you don't want to get a sample that is it overrepresents short people, or a sample that overrepresents tall people, because then when you use it and make statistics on it, it's going to look like the average height is taller or shorter than the average height of someone, a 13-year-old female in the United States is. So we are really focused on getting a representative sample. So what are some things that would make a sample non-representative? Well, what we call biases. Bias means that it's non-representative, meaning the sample that you get or the conclusion that you draw doesn't represent the population you want to study. Okay, so it doesn't represent population. Okay, so for instance, if you collect information about just one geographic area, so let's say, okay, I just want to study the 13-year-old females in this school. So we're all generally from a certain area of Brooklyn. Now, that geographic area might represent a sort of bias. So people might be taller or shorter in an area than another area. It might be genetically similar. So if you're in a small town, people might be genetically similar if they have a lot of relatives in that town, which means that being tall or short is part of its genetics. So you don't want to have someone who's genetically similar if that's a factor that you're studying. So if you're studying a genetic factor, you don't want to have people who are genetically similar. People in an area might be exposed to a certain environmental stress that may have changed their heights over 1 or 2 generations. So I know certainly in large cities there's a lot of pollution. Now maybe pollution stunts growth, maybe exposure to pollution. A mother's exposure to pollution causes a baby to be stunted growth-wise in utero. So that may represent a bias. So if you just choose people in a certain geographic area, there are several concerns with that. If you're trying to study the population of the entire United States. Now, if you're trying to study the population of just Brooklyn or just your school, then certainly it would not create a bias if you studied all the 13-year-old females in the school, because your population is just the school. But if you're trying to mention something about the population of the United States, then you can't use just the school or just an area of, say, a town or even something as large as Brooklyn. Okay, so what you want is a representative sample. Now, a representative sample is a sample that represents the population being studied. Okay, the key word here is the population that you're choosing to study. Below are 3 common ways to get a representative sample. So you can do a simple random sample, find a way to randomize the population, like assigning each person a number, and then drawing that number out of a hat. Okay, so an example of this would be a Gallup poll. So around major elections, you see this company called Gallup, and what it does is it polls people to try to get their feelings on certain political beliefs or how they're going to vote in an election. And so what they do is they assign everybody in America with a number, and they find some way of generating a random number. They often use something called a random number generator. And as soon as that number pulls up, they call the person associated with that number, and they ask the questions to that person. So that's a way to generate a random sample. That's a way to generate a representative sample. Now, there may be a few biases, like you're contacting people with potentially over the telephone. So it may be that people who have telephones are voting a certain way. But certainly now that there's a prevalence in cell phones, it's not that much of a bias because most people have either a landline or a cell phone. There's also a potential bias because people who answer those questions are also people who are likely to maybe want to state their beliefs. So it may be that they are leaning in a certain direction and they feel strongly with that. So like this is often what happens when you go to, let's say you go to a restaurant and you have a horrible experience at that restaurant. Well, oftentimes you'll try to go and figure out a way to tell somebody about that experience, and online rating systems are often what people use. So if you look on an online rating system for a restaurant, it often will overrepresent the amount of people who had a hard time at that restaurant. Okay, so a convenience sample is a technique where the researcher asks everyone in a certain area for information. Okay, but it can be biased if the reason that the people are in that area has something to do with what you are studying. So an example is a class poll about favorite food. Okay, people have come into the class we don't categorize people by class based on their favorite food. So coming into a class and asking people what their favorite food is fine. It wouldn't have any biases in that. But if you go to a pizza place and you say, okay, everybody in this pizza place, why don't you tell me what your favorite food is? Well, then you potentially are overrepresenting people who have pizza as their favorite food because they've gathered in that spot because they're eating pizza. So that, for instance, could be biased and most likely is biased, right? Systematic sampling is where a researcher has a system for choosing samples. So, for instance, a quality control manager chooses 1 in every 100 light bulbs in the factory assembly line to check for defects. So it's random in that they weren't put on the conveyor belt in the same way, but it's systematic where they have a system of choosing that random sample. Okay. Now, the next thing that we have to go over is interpreting graphs of data. Okay, so this is a graph that I found yesterday, wealth inequality in America. All right, so let's try to figure out the components of this graph. I've outlined some of the words in bold so that you can see them, but so the first time is actual. It's the actual distribution of wealth in the United States. And the second one is what Americans think the distribution is. And the next one is distribution that 92% of people would choose as ideal. Okay, so let's look at our categories. The purple category represents the bottom 20%. The aquamarine category represents the second 20%. The green is the middle 20%. So it looks like it's been divided into 20%. And then the fourth 20% and the top 20%. Okay? Okay, so to start to interpret this graph, let's look at what we have. These three, so when we say 20%, we're talking about people who make a certain amount of money in our society. So these three people the middle 20% would be considered the middle class. So there's a lower, a middle, and an upper middle class. And this would be the wealthy, and this would be what we would consider the poor. Okay. Now let's look at what the ideal is. So this is actually, it looks like a bar graph, but it's actually sort of a pie chart because they take this rectangle and they split it into multiple different parts. So the whole rectangle itself is 100%, but then they split it into different parts to represent how much money these different portions of our society have. So let's say that, so the whole net worth of, I just watched this little video on this, and they told me the whole net worth of America is $54 trillion. Okay, but let's make it a little bit easier by thinking of it as $100. So let's say America only had $100. Okay, the question is, how is that $100 split up into the poor, the middle classes, and the wealthy? All right, so the ideal bar graph shows that it's almost equal, except that the top 20%, the wealthy people, would have more of the $100. The middle classes would have much more than half of the $100. So like more than $50 would be split between the three middle classes. And the poor would have, it looks like, let's see if there's a halfway mark here so we can sort of measure. So if this is about halfway and this is about a quarter, so the poor would look like they would get maybe about $12 or $13 out of the $100, okay? So what this is saying is, and this is based on a Harvard business economist asked thousands of people, both Republican and Democrat, what they thought the ideal distribution is, and they came up with this graph right here. Now, what they think it is, so they recognize there's a difference between what they think it is and what the ideal is. So what they think it is that so let's look at this. It looks like these are a nice way to look at this. So 1, 2, 3, 4, there are 5 categories here. So this is about halfway. Okay, so let's do that. That's about halfway. Now, it looks like they're saying that people think that the wealthy takes up more than $50 of that $100, right? Because their bar is more than half of it. So if America only made $100 every year, then the wealthy own more than 50% of that $100. They own more than $50. Whereas the three middle classes own probably together about less than 50%, right? So it looks like they're about, let's see, this is probably about 10% with the bit of the wealthy and the poor together, the little purple part and the rest of the red part. So this is probably about 30%. So about $30 is split between the three middle classes. Again, if America made $100 a year, then $30 would be owned by the three middle classes together. And it looks like the poor would own about 10% of that $100, right? So the net worth of America is sort of how much money we make on the products that we make every year. Okay, so the actual distribution, though, is much more startling. The actual distribution says that the top 20%, the wealthy people, own just about, so it looks like, okay, if we were to split this into quarters now, let's do that because it looks like we're going to need to do that. So if that red line is half, then about, let's see, this would be about a quarter. Okay, so they definitely own the $50 here. Okay, so they definitely own 50 here. Now, they would also own this 25 that's in a quarter. They'd also own a little bit more of this portion right here. So that's about, let's see, if this is 25, this is probably about $17, and this is probably about $8. So it would, the actual is saying that the top 20% of the earners, actually they own about $83 out of the $100 that America makes in a year, whereas the $17 remaining from the $100 is owned by the three middle classes and the poor. The poor is so small on the scale that you can't even really tell where it is. Now, the video that I watched actually broke it down a little further, and they made two other charts to show you what this looks like. Now, again, I'm just focusing on what the bar graph about what America thinks in their actual. So they said, what they did was they broke down these 100 people for, they broke them down into, they pretended America was only about 100 people. And they made this little graph right here. It's kind of like a dot plot. And they're showing that what we think it is we think that it's, the wealth is distributed in a way that it goes up and up and up as we increase. So it's kind of like a steady increase, except when you get to the top 20% and they own more of America's wealth faster. But the actual is that it's very, very low until you get to the top 20%. And even part of the top 20% is segmented off. It looks, and they show another picture where they talk about the top 1% of the earners. Here, the people who make about, their salaries are in the 1% category. They own so much more that they actually can't even put it on the scale of the graph here. So it's a pretty startling result. But that's how you interpret these graphs. I mean, it takes a lot of, you can tell, I spent a lot of time talking about it. It takes a lot of analysis to interpret graphs. Now, there's a few things that might be misleading about a graph. First of all, a lot of times people use a pictogram to represent data. And this is a pictogram showing crime rates in the United States for the years 1990, 1995, and 2000. So they're looking at how they increased over 5 years. So the first one's about 14.5, I could estimate about 14.5 million. The second one's about 13.9 million. And the third one's, so it looks like as the years are increasing, the rates, the crime rate in the United States is decreasing. So this is about 11.9 million. Now, between these 2 years, it's only decreased about 0.6 million or 600,000. But the picture itself is decreasing in size. Now, you have to be careful about something decreasing in size because a size is a two-dimensional thing. It's actually two factors. There's the height or the length and the width of it, right? The length and the width. So if you decrease both the length and the width of something, that means that you're actually decreasing it much faster, because the area of this police car is much smaller. The ratio of the areas of the police car is much smaller than the ratio of the decrease. Okay? And that's because we decreased an area. We didn't decrease the other ones, they kept the width of the bar the same, but they just decreased the areas within that width of the bar to show. Whereas right now, they're keeping the police car, they're changing both the length and the width of the police car to change the area of the police car. Okay, and that decreases it much faster. The ratios of these two areas are much smaller than the ratio of the actual decrease in crime. Okay, if you look at this third police car, it looks like it's much smaller than that first police car, where if you look at the rate of decrease, well, it's decreased, you know, a certain amount, but it's still up at 11.9 million. Okay. Another misleading thing about a graph is a break may have been used, in which case the graph is sort of zoomed in. So this is the average weight of subjects over a 6-month period. So it goes 1, 2, 3, 4, 5, 6 months, and the weight is 199 the weight only goes from 199 to 200 pounds. But if you look at it, it looks like a dramatic increase. This line looks like it's going down pretty fast. But then we look at the actual weights. Look at this right here, right? The actual difference between the bottom scale and the top scale is only 1 pound, right? So this right here, this is a really extreme case of someone zooming in on something. So the decrease in weight, they only lost about 0.9 pounds across 6 months. And so it wasn't, I mean, it was a steady decline, but it wasn't as steady as it looks across the 6 months. So a break may have been used, and they didn't, right here, they didn't even put that break there. So you're supposed to put this break here if you're going to use it. So right in this interval is the points 0 to 1 point, or 189.9. Okay. Now, another thing that might be a problem is the scale might not be consistent. So let's look at the scale on the y-axis. So it goes up by, it looks like it's going up by 100. So 100 to 200 to 300, 400, 500. That scale is okay. But here, this is an increase of 5 years. Here, that's an increase of 5 years. Here, that's an increase of 9 years. Here, that's an increase of 1 year. Here, that's 2, and here, that's 4. Okay, the scale has to be consistent. So it looks like it's, you know, going up at a certain amount, but the thing is that there's the intervals between the time are different for each one. So there, I mean, what happened between between the 9-year difference here, right? Like it's probably not as steady as it appears to be. So if the scale is not consistent, then the graph is misleading. So to reverse that, you may have to make sure your scale is consistent in order for your graph to be also consistent. Okay, so that's the end of the lesson today. We talked about things that might be misleading in graphs. We talked about how to interpret graphs of data. We talked about a representative sample and biases, and how we can collect data. Okay, and the difference between quantitative and qualitative data.